Okay, so let's take a look at this problem right here. It says 4x plus 3y equals 14 and 5x plus 7y equals 11. So we need to find the value of x and the value of y that make these two equations both true. However, it's not going to be so simple because we can't just find one variable without having, if we find one variable, it may not be correct with it may not have yield the correct value with the other variables. We could find x fine, but the y value may not make the equations true. Like, they might make one of them true, but it might not make the other true. Essentially, when you have more than one variable, you can't do it the same way as you would do it normally, and this is called simultaneous equations, because you need to work with these equations at the same time to get two different variables that will fit both equations. Well, how do we do it then? Well, in this case, this is a linear one because there is no quadratic or anything. It's all to the power of 1. So we have x here, which is just to the power of 1, y to the power of 1, y to the power of 1, x to the power of 1. So there's no y squared or x cubed or anything like that. That's all gone. So simultaneous means at the same time. So we need to figure out a way to evaluate them both at the same time. What could we do? Well, the first method that is pretty easy with linear ones is called elimination. So how does elimination work? Well, it works by making the equation so that one variable is the same on both sides, and then taking away that variable using normal subtraction and looking at the other variable and solving for that. So let me explain that more because I think that's a bit difficult to understand just by words. So let's find a way to isolate the y value. That means we're going to need to make the x value the same. These values. So how are we going to make 4x and 5x the same? Well, we could multiply each of the equations by 5 and by 4 respectively, because then that would give them both 20x. So if we multiply this equation by 5, it gives us 20x plus, and then 5 times 3, so it's 15y, equals 14 times 5, which is 70. And on the other side, when we're multiplying by 4, we get 20x as well, plus 28y, which is equal to 44. Yeah. So now what can we do? Well, we can actually use just normal subtraction, which would thereby eliminate this x one because it'll just give us 0x, which is just 0. So we've taken away the x value, and then we do 15 minus 28y, as we see here, which gives us negative 13y. And then we do 70 minus 44, as we see here, which gives us 26. So now we can solve for y without having to worry about x. So y is equal to 26 over negative 13, which is equal to negative 2. Well, now this value of y means that these equations will be true if we find the value of x. So let's just plug into one of the equations now. 4x plus 3, and then we substitute the value of y we got in, is equal to 14, which means that 4x minus 6 is equal to 14. So 4x is equal to 20, and x is equal to 5. So the answer is y equals negative 2, and x equals 5. And we did this by getting rid of one of the variables. So it would actually work if you try to get rid of the y value. We could just multiply this equation. Wait, let me just rub this out. We could just multiply this equation by 7 and this one by 3. And it would give the same value of y, which we could then subtract off and get rid of. And then we could solve for x instead. Either way, it will yield the same results because we're just doing it the opposite way. So that's the first method. Now let's look at the second method. So let's bring up our first question again, which was 4x plus 3y is equal to 14, and 5x plus 7y is equal to 11. Now, there's a second method we can use. This one, it might be more difficult to do with because the coefficients are quite large, but let's still do it. So the other method is substitution. And I'm sure you've heard it before. It's when you replace something with another value. So what we have to do is we take one of the equations. Let's take this one because, let's take this equation because it has smaller coefficients of x and y. And we isolate one variable. So let's say we want to isolate y. So we can write as 4x plus 3y equals 14. Rearrange to find y using our rearranging skills. 3y equals 14 minus 4x. So y is equal to 14 minus 4x divided by 3. And now what we can do is substitute our value of y into here. This would thereby take away the y value and leave it with only x so that we can solve for x. We could do it the opposite way as well, but let's just do it for y in this case. So now we can write it as 5x plus 7, and then we multiply it by 14 minus 4x over 3, and it's equal to 11. So 5x plus, and then 7 times 14 is 98, I think. Yes. 98 minus 28x over 3, which is equal to 11. Which means that we can make this the common denominator, which means it would be 15x plus 98 minus 28x equals 11. Oh, this is over 3, sorry. Then we can make it 98 minus 13x is equal to 33 if we multiply it out. So negative 13x equals, and then we can do 33 minus 98, which is equal to negative 65. Oops. So x is equal to negative 65 over negative 13, which is equal to 5, positive 5. And it gave the same value as our last method, which was that x equals 5. In this case, it would take more time because the equations are not so suited for substitution in that they have very big coefficients. Well, we could use the same method. This time we just substitute our value of x back in. So it would be 4 times x, which is 5 in this case, plus 3y is equal to 14, and we can solve for y, which would give us 20 plus 3y is equal to 14, and 3y, oops, my 3's aren't looking very good. 3y equals negative 6, which means that y is equal to negative 2. So it still gave us the same answers as last time, they're just two alternate ways of doing them. Okay, so we've got another system of equations here. X squared plus 2y is equal to 9, and y minus x at the same time is equal to 3. So you may be thinking, we can just use elimination like before because it worked really well last time. But the reason why we can't do it this time is because this is not a linear set of equations. The last one was because the degree to which x and y were raised to was 1. Here, we do have variables that are raised to the power of 1, but this one here is raised to the power of 2. So we cannot use elimination like we did before. Instead, what we must do is rely on substitution, which can still work. This is because this equation over here is very easy to manipulate for substitution, and then we can ping in our value over here. So in this case, what immediately stands out is the fact that y is so easy to manipulate. We can just bring negative x to this side and then plonk the value of y into here. So let's do that. Let's just get rid of that. Okay, so y minus x is equal to 3. Well, at the same time, y is equal to x plus 3, that means. And now we can substitute our value of y into here, which would give us x squared plus 2x plus 3, which is equal to 9. Always put it in brackets just in case, because you want this to multiply by each term in here. So let's continue. X squared plus 2x plus 6 equals 9, which means x squared plus 2x minus 3 equals 0. And this is a quadratic. We can easily factor it. Just watch my video on factoring it in this playlist. It's called Factorizing Quadratics, and I use two methods to show how easy it is. And we can just use inspection here to do x plus 3, times x minus 1, which is equal to 0. And that means the solutions are x equals negative 3 and 1. Well, we just realized that we have two values of x. That means that there are two different solutions. So we should be getting two values of y as well. So how do we do this? We can just substitute each value of x. So if x equals -3, and let's just use this equation here, because it is so easy to manipulate. Y is equal to, just give me a second. Sorry, y minus 3 is equal to 3. So y plus 3 equals 3, which means y is equal to 0. And then on the other side, we have if x is equal to 1, that means y minus 1 is equal to 3. So y is equal to 4. So here are two solutions. When x is equal to -3, y is equal to 0. And when x is equal to 1, y is equal to 4. So when we have a quadratic, when we have a value that's raised to the power of 2, that means we will probably get two sets of solutions. And we might get even more if we get other kind of problems like quartics and cubics. But for now, this is what we're given. We can do one more example after this. And after I show the example, pause the video if you'd like to attempt it. Okay, so here's another set of equations. Now, given what we just covered in the last two questions, pause the video if you'd like to try and solve this. If not, let's go ahead with it right now. So, immediately what stands out is y is very easy to separate in this equation. We can simply rewrite it as y equals 8 and then bring the 3x to the other side, so it's minus 3x. And now we can substitute that back in here. And we have to use a little bit of quadratics and expansion to solve this, because it's y squared that we're inputting it into, so we're going to have to square it. So 3x squared plus 8 minus 3x squared equals 28. So 3x squared plus, and then the way we write squared, if we square something, it's always, if it's a plus b squared, it's always written as a squared plus b squared plus 2ab. If it's a minus b squared, it's equal to a squared plus b squared minus 2ab. Just some basic knowledge with squaring things. If you want to look at binomial theorem to look at things that are raised to a higher power, you may do so. But for now, let's focus on this problem. Since it's 8 minus 3x, so we can figure out that it's, that it's 64 because that's a squared. And then it's plus b squared, so negative 3x squared is plus 9x squared. And then minus 2ab. So negative 2 times 8 is negative 16 times 3 is equal to negative 48 times x equals negative 48x, which is equal to 28. So that means we can collect like terms, so 12x squared plus 64. Actually, no, let's not write the 64 here. Let's write it in descending powers of x. So it's negative 48x here. And then we bring this to this side. So 64 minus 28 is 36. Plus 36 is equal to 0. But we don't have to stop there. We can actually factorize this more by getting rid of the 12, because it's divisible by every single term. So we can do 12x squared minus 4x plus 3 is equal to 0, and then actually cancel it out, because when you divide 0 by 12, it's still 0. So we have x squared minus 4x plus 3 is equal to 0. And by inspection, we can see that x minus 3, x minus 1 will yield this correct result. So x is equal to 3 and 1. And we expected this because it's raised to the second power, there would be two sets of solutions. So when x is equal to 3, we can use this equation that we generated over here. So y is equal to 8 minus 3 times 3. So y is equal to 8 minus 9, and y is equal to negative 1. But when x equals 1, y is equal to 8 minus 3, because 3 times 1 is just 3. So y is equal to 5. So our two sets of solutions in this case is x equals 3 and y equals negative 1. and x equals 1 and y equals 5. And we can check it with both these equations, but we don't need to because we've done it correctly. Anyway, that's it with simultaneous equations. I think that's all. This question and the last question are more ADMATH style questions. So in CIM, I wouldn't be too worried. You can use a calculator to actually graph it. I'll make a video on how you can actually solve these kind of equations on the calculator later. But for now, actually, that's not really necessary. You should see how to do it algebraically, because algebraically will also make it a lot easier. With the calculator, there is still room to make errors. And you can check on the calculator, but it's best to know how to do it algebraically, so that in case you don't have the calculator, the graphing calculator, I mean, you can't really do it with the green calculator, then you still have the means to do it. Especially in ADMATH, when this question will come up, you wouldn't have the calculator. If you're in CIM, then you probably would be able to with the calculator. And you're more likely to get linear sets of simultaneous equations in CIM with the non-calculator paper. Anyways, I'll put some worksheets in the description. If you need any help, let me know in the comments. And thanks for watching.